Now our topic is about the IPSec VPN. Because about the IPSec VPN also belong to the layer 3 VPN, and it can provide more security function. So about this topic, we will explain. The first one is what's a concept and what's a scenario of the IPSec VPN has. And also we will explain some principle how to work of the VPN can help us to protect the traffic. In the second part, we will provide some configuration exam, how to deploy the IPSec VPN. If you want to use this function, what's some special command you must add in your devices. So this is a basic one. First, let's see what is IPSec VPN. About the IPSec VPN, we will use the IPSec protocol. And about this protocol, actually this is a protocol family. We will have lots of protocol and algorithm we choose in the IPSec. Then we can provide the security communication channel for private networks. And also, because this belongs to a VPN technology, so we can pass through the public network. And we can ensure the security of data transmission through the encrypted channel. So this is a basic one. Like this topology, if we have one branches in the one headquarters, and they have different internet. Maybe this internet belongs to the private network, right? And between them, we have the internet, and this is the public network. So in the branch and headquarters, we can establish the IPSec tunnel. Then the user can use the tunnel to force the message out. But the special feature for the IPSec VPN is we can provide the security. So we can help the router to encapsulate or maybe provide the authentication function. So this is the special functions that we want to choose the IPSec VPN. And then let's see how to meet the requirement. Why we can protect our message. The first, let's say, is the IPSec architecture. In the architecture, the first part is the security protocol. And the protocol function is responsible for data protection. For example, if you want to ping from headquarters to branches, in this ping message, we will use the RCNP protocol, right? And we will use some RCNP packets. In these packets, we say belong to the data protection, okay? And we have two protocols. One is AH and another one is ESP. And about these two protocols detail, we also will explain later. But we have to know the main function for AH is we can provide the authentication. That means if your RCNP packets transmit into the public network, maybe someone get it and encapsulate wrong packets. That means we change some message, change some information. So if the receiver gets this packet, we can provide authentication. If we detect some information already changed, that means this message cannot be used, so we can directly discard it. So this is a function for the AH. We can provide authentication. And about the ESP, ESP also can provide the authentication to detect the message already changed or not. And except this function, it also can provide the encryption. That means, for example, maybe your message is 123. If we don't encrypt it, if someone uses the tool to get the message, we can see the detail is 123. But if you encapsulate, maybe the message will become at. 7, and 9. So although maybe you use some tool to get the packets, but finally you only can see this information. We don't know the origin message is 1, 2, 3. So this one will be more security for our message. So there are 2 types of security protocol. So maybe someone think ESP is better than AH because we can protect the message better. But if you choose the ESP, you need more resources to deal with the origin message. Maybe you will increase the delay, right? To increase the delay time. And also maybe your devices need more core resources to deal with a message. So if you want to forward some other message, also the resources is not enough. We will discuss some message, something like this. So depends on your real network, you choose the AH or ESP, right? So this is the first part of the IPSec architecture. We have to use a security protocol. The second one is the operating mode. And about the operating mode, we have 2 parts, transport mode and tunnel mode. And about the transport mode, usually deploys the client-to-client protection. That means the tunnel will directly establish in the terminal and the terminal. And the origin IP packet is not changed. So this mode usually used between 2 hosts, not like the VPN we explained in the before part. We have to add some new header. About this mode, we will directly to use the original IP packets. So that means all the hosts can provide the public part. So this is the first one. And about the second one, about the tunnel, we can establish the site-to-site protection. And about this tunnel, we will directly add a new IP header. Okay, so if your client uses a private IP address, we also can provide the VPN function because we will add a new IP header. And in the IP header, we can use some public information. So this is the basic about the operating mode. And the second part is about the key manager. What's the function of the key? Because the first part, we choose AH or maybe ESP, right? We can provide different level of the security, but how to provide the authentication, how to provide the encryption, we have to use the algorithm. So when we choose the AH or ESP, we also have to choose which detailed algorithm you want to use. Then we will take the message 1, 2, 3. And the algorithm together, right? Algorithm together. Then we will use 1 key. For example, the key is 7. These 3 parts, we will do a calculation. The user packets, the algorithm, and the key. 3 parts. So the algorithm, when we do the configuration, we can directly choose, but how to get the key? Because about the algorithm, 2 sides must be same. The key, 2 sides also must be same. And how to manage the key? First one, we can directly manually configure the key, right? Configure the key to become 1, 2, 3, or maybe 5, 6, 7, something like this. Another management is we can use special protocol, we call it IKE. And if we deploy IKE between 2 devices, then they can exchange some packets and use some special algorithm finally to get a key. And this key, maybe when you check your command, show your running configuration, you cannot see the detailed key, and it also is more security. So this is a tool to help us how to get the key. This is a tool to help us which security protocol you use and also which algorithm you want to use. And this part is a message directly from the client. Finally, we can get a security message. Then this message can be forwarded pass through the public network. So this is the IPSec architecture. Then we will explain one by one. What's the detailed difference of the security protocol? What's the difference of the operating mode? And also what's the difference of your key management? So first, let's see the transport mode. For example, now we have site A and site B. Site A maybe belong to the branch and the site B belong to the headquarters. Between them, there is the internet. If you want to use a transport mode, that means we also need to deploy the IPSec. But the IPSec will directly establish in the terminal, right? Establishes the IPSec tunnel, and then we can encrypt the message. So the message will be directly forwarded between these two terminals. And in this mode, the headquarters network device and the branches network device, they don't know you already use the IPSec VPN to protect our message. When we receive the message from terminal, according to your IP routing table, I will directly forward the message into the internet. And then the headquarters receive, according to your IP routing table, I will directly forward it to the terminal. So in this process, the headquarters and the branches network device, maybe it's your EG, maybe it's your router, don't know any information for the IPSec VPN. So your terminal also must support to have a public IP address, right? Because we don't add a new header. So this is transport mode. And another is your terminal mode, your tunnel mode. About the tunnel mode, we support to establish the VPN in two sites. This site you can think is layer 3 devices. So we also have to establish the tunnel, but in the branch and headquarters layer 3 network device. Then we can encrypt the message. But for all the terminals, they don't know finally the message need to be encapsulated into the IPSec VPN. I only send out the normal message to the tunnel, right? And the tunnel will help us protect the message and then pass through the internet and finally send out to the receiver. So this is a tunnel mode. About this mode, we can support lots of terminals, but all of them use the same tunnel. So only the layer 3 device establishes the IPSec tunnel is enough. So there are two different types. Usually we will use the IPSec tunnel mode. And another one is your IPSec SA. What means SA? SA is Security Association. And it is agreement established between two IPSec entries through the negotiation and determine what to protect, how to protect, and who to protect. This is a function of the SA. So in the SA, we have lots of information, and it is uniquely identified by a triple, the SPI, IS index. Different SA, we will have index number. And we also have the IP destination address. For example, if left is branch, the IP destination address is the IP address of the headquarters. And also we will have security protocol identify. You also have to select you want to use H or maybe ESP. And also which algorithm you want to use, something like this. So this is the SA information and determines how to protect the message, like our RCNP packets. The protocol, which one you want to use, right? And also how to encapsulate your message. You want to use transport, or maybe you want to use the tunnel. And also the verification algorithm and the encryption algorithm. This algorithm will provide our function to make sure the message never be changed. And this is protect our message. If someone gets the information, they also cannot realize what's the original message. And also which key you want to use, right? If you want to have if you want to use IKE to dynamically negotiate the message, negotiate the key, this key also have lifetime. Maybe the lifetime is ready, then we will negotiate a new key to more protect our message. And also some anti-reply window counter, something like this. So the process is, first, if you have two routers, route 1 and also route 2. After you add the configuration, then they will do the negotiation. Finally, to have the IPSec SA. Then when we receive the message, route 1 receives a message. Maybe you have lots of SA, right? SA1, SA2, and also lots of SA. Because in the SA, maybe you will establish the tunnel with 2, and also establish the tunnel with 3, and also establish with the tunnel with 4. Maybe the same tunnel with 2, but different service. Maybe you want to provide different level security, right? If the message belongs to the ping message, RCNP, I think H is enough. But if your message belongs to your voice message, I think this need high security. Maybe we will choose ESP. So different choice. Also for different algorithm, they must located in different SA. So in one router, maybe you will find a lot of SAs. And if we establish the SA successful, then when we receive the message, I will check belong to which one. I will select, for example, compare first, second one, I will choose the second SA. Then we will add maybe new header, maybe provide the encryption, something like this, then force the message out. When the route 2 receives this message, I also will check which SA can help us to do decryption, right? Because now maybe you receive the message is not the original. I have to make them to become the original message, then to the destination, to your terminal. So we also, in the route 2, we maybe have lots of SA to select the match the SA and then to make the message to become original one. So this is a function of the SA. The SA is very important. If you add the configuration, but finally you cannot establish SA successful, then the message cannot be protected. And the next part is each IPSec SA is unidirectional. So maybe this SA1 only protects the message from left to right, but from right to left one, the SA is another one. Is another one. For example, we will use SA1 to protect the message from left to right. But when we receive the message from right to left, I will use SA2 to do some other operation. Because about one SA, we will find this is a triple, right? Identified by a triple. The index number, one SA will have unique index number. And another is IP destination address, because from left to right, the destination IP address is this interface. But from right to left, the destination IP address is route 1 interface. So this is unidirectional. So if you want to ping from left to right and can receive the ICMP reply, on the round 1, at least 2 SA located. So this is IPSec SA. It's very important. And about the IPSec SA, you can create manually, right? Everything will defined by administrator and also generate through the IKE negotiation. It is more security. So in the IPSec VPN, the very important one is how to know the principle of the IKE. And we see about the IPSec SA, we can support 2 functions, 2 types, manually config or maybe IKE auto management. And about the manually configuration, everything will be created manually and also maintained by the administrator. So if some algorithm or maybe key, when you do the configuration, you add the wrong parameters, maybe the SA cannot establish successful. And we support if your network is not so security and your message is very important, you can negotiate the information automatically by IKE. But pay attention, the IKE negotiates the message, the key finally will used by IPSec SA to protect our user message, not directly used for the user message. So this one is very important. And about the IKE, we also will establish the IKE SA. Okay, then IKE SA will help us to establish the IPSec SA. So the process is, first we will exchange some IKE message. Which algorithm we want to use to negotiate some parameters of IKE, which algorithm we want to use. And then IKE will establish the IKE SA. Right? And in the IKE SA is used to help us to establish the IPSec SA. Okay, and finally, IPSec SA can help us to protect our user message like RCNP. This belongs to the user message. So this is the whole process, how to protect our traffic. This is a basic one. So about this part, we explain what is IPSec VPN and what's the advantage and what's the IPSec architecture, right? And we also explain the 2 modes of IPSec. One is transport and another one is tunnel. And these 2 modes and also the security protocol, AH and ESP, and what's the algorithm we want to use. Everything will be located in the IPSec SA. So the IPSec SA is very important. In the next part, we will explain 2 detailed security protocol, AH and ESP. What's the difference of these 2 protocols and how to protect our message more security. Okay, so the first part is ready. Thank you.